everyone, and welcome back to twitch.tv/AWS. I'm Abby. I work here at AWS. I am joined by Meyer from Wix, Rohisha from Accenture, and Aditya, who is a PM here at Amazon. So first things first, guys, thank you all for joining me. Aditya, can you start us off a little bit and tell us about what you launched this morning?
Absolutely. So today, the keynote, we launched deep learning containers. And deep learning containers are a set of Docker images that are pre-packaged for deep learning workloads in TensorFlow and MXNet. And we built these images so that customers can do their own training and inference across AWS services like Elastic Container Service and Elastic Container Service for Kubernetes.
Gotcha. And not that I'm biased at all, but
be biased.
I'm biased. I know that historically we've also produced deep learning AMIs or AMIs, depending on whether you work at Amazon or you don't. Extremely hot topic. Tell us about containers and how and why customers are using them and why we've started producing deep learning container images.
Definitely, it's a great question. So I'm biased towards ARMY, so I'll use that.
Wow.
And hopefully that doesn't
I'm no
rile
longer
up.
speaking to each other.
So deep learning armies provide a really great environment for developers to get started, do their research, build models and train models. But what we've seen with customers and what they've told us is when they get into production environments, when they need the modularity and scalability that containers bring, they prefer using Docker environments. And customers today have been doing this themselves. So they would build, maintain, optimize, integrate these container images from scratch, and that's a lot of undifferentiated heavy lifting. So what we wanted to do was give the same optimized environments, give the same ease of use that we currently deliver with the deep learning AMIs, and make that available in a Docker setting that customers can use to build their own custom containers across services like ECS and EKS.
A little bit of the details. Which frameworks are you supporting with deep learning containers at launch today?
So today at launch, we are supporting TensorFlow and MXNet, and we will support PyTorch soon as well.
Awesome, cool. Can you tell us a little bit about how these deep learning containers are solving kind of the challenges around how developers are working and using these deep learning AMIs?
So today, developers and data scientists that want to use Docker containers have to spend a lot of time and resources in building these images themselves, testing them, integrating them, optimizing them for performance and scale. And because the community that builds these deep learning frameworks and libraries is constantly changing, constantly evolving, it's not a one-off, one-time investment. It's a sustained investment where you have to continuously optimize, build, test these images again and again. And that makes this a substantial investment for a company to make that's not really unique to their core skills, core strengths in their product. So deep learning containers take away all of this heavy lifting. They give you an image that's already optimized for AWS, and well-tested and integrated with the container services where you would want to deploy them.
And optimize in this particular case means that all the things I need to run the framework are already installed. All the dependencies I need they're already part of that image, so I don't have to go hunting for it.
Right.
They're already there.
So there's two aspects to that. So there's the build optimization where it works out of the box. There's no tuning, no configuration needed. All the dependencies, all the low-level libraries like NVIDIA CUDA, Intel MKL are already included. But then we're also building from source and ensuring that these frameworks get the highest performance possible on AWS. So we integrate with libraries like Horovod, we integrate with Intel MKL to get customers the best performance without them having to do any optimization on their part.
Gotcha. Passing it over a little bit to Meyer, can you tell us a little bit about Wix and what you guys are doing with deep learning?
Sure. So Wix is the preeminent platform for building websites. Essentially, there are three main products. The first product is Wix Editor. That provides an easy drag and drop interface for people that are familiar, let's say, with PowerPoint. They'll be able to easily create their own websites and build an online presence. On the other extreme, we have users who have zero technical ability. I mean, they're not really that familiar with, let's say, with PowerPoint. So we built a product called ADI that stands for Artificial Design Intelligence. That's a platform which essentially generates a website automatically for the user. The user just has to sort of upload their content, fill in the text, upload their images, and they have a website pre-built and ready for them to publish. And then on the other extreme, there's Wix Code, which is aimed at more advanced user that provides users with JavaScript integration and more extensive backend support. So in terms of deep learning in Wix, we work within three main domains. The first domain is within Wix Media, where we build models to help improve user content. For example, computational photography, we have models such as super resolution models and auto Photoshop, which provide the user with an automated design experience within the Wix platform. The other domain that we work in is automated web layout optimization that fits into the ADI platform that I mentioned earlier. We have models that automatically perform web layouts. And then the third domain is sort of classical business domain, such as forecasting. So that within each of those domains, we use deep learning to solve various problems in those domains.
So where does kind of the challenges and where do deep learning containers fit into that?
So my team is responsible for the research phase. That involves training and testing models, performing experiments. So we've been working within the deep learning AMI.
You had to make both of us happy now.
Yes, I made both of you happy. The truth is, before I spoke to anyone in Amazon, I called it AMI. So.
Me too.
Yeah. So.
Maybe we should settle in Amy.
There we go.
We should, yeah. No, everyone will be unhappy.
Amy is what it is.
Yeah. So yes, I mean, and the truth is, we've been very happy with that platform. We actually did a comparison with some of your competitors, and we actually found it to be far more optimized, and so most of our projects are utilized up to now have utilized that. The problem is that because our research, the research phase and the production phase are sort of separated, two separate teams are responsible for each of those parts of the project. So what happens is it turns out to be a bit of a mismatch between the research environment and production environment. And once we've trained and tested our models and we push to production, then we go through a whole phase of testing and ensuring that what's running in production matches what we see in our evaluation. And this process can be quite cumbersome. So what we're hoping is that these deep learning containers can solve that problem for us, and that we can train, test, and deploy in a single container in the same environment for research and production.
And just one thing I can quickly add, and that's really the core value proposition from a production standpoint. These are production-ready containers, so we want customers to be able to use them throughout the pipeline, right from training all the way to deployment and production.
Well, it's similar, right, to the monolith to microservices story that people were telling, and they told it again in the keynote this morning, but that's been really common for a while, right? Which is that if you have these big AMIs or images or however you're doing it, there's a lot of drift between how I'm doing it, how you're doing it, how you're doing it, between my computer and production. I think that was a lot of the driver for people to use containers in the first place, was just that I could then use that same image across everywhere, and there was less of this drift.
Yeah, you get this isolated environment that you know works well, and you can take it anywhere.
Exactly. Rohisha, Accenture, can you tell us a little bit about what you guys are working on?
Yeah, so I'm a data scientist at Accenture, so I work with our clients in different industries to figure out how to use their data and make sense of it. This can be anything from smaller prototypes to see what's possible to larger scale machine learning pipelines and deployments.
Can you tell us about the same question that I asked Meyer? Can you tell us a little bit about the challenges and kind of your workflow, or what your workflow looks like, and how deep learning containers are fitting into that?
Yeah, so containers are great. They allow you to encapsulate everything you need for environment setup and use that as a template in the container image again and again in different places. One time I was starting a project, and the project manager had instinctively allocated a couple days for setup and environment setup, and I was able to find a container that actually fit our needs quite well, so that days turned into a few minutes when I was able to just deploy from the container. The challenge with deep learning is that it's an evolving field, and the frameworks and tech stack for doing deep learning are also continuously evolving. So as a data scientist or machine learning engineer, you need to keep track of not only your favorite frameworks, so TensorFlow, MXNet, Caffe, PyTorch, etc., but also the dependencies for working with that framework and any optimizations that exist for dealing with the underlying hardware. So Intel MKL if you're using CPUs, or NVIDIA CUDA for GPUs. And then also the cloud platform and the optimizations that exist for each cloud platform. So it's a lot to keep track of. And now with deep learning containers, we know that on AWS, we'll have a container that's ready for us to use, and that has been optimized for AWS and the workloads that we want to run, so inference, training, in different frameworks.
I guess for both of you too, how does that end up changing your workflow, right? So like, does everyone go and pull them from a registry? Do you pass them around? Do you pull them, do some customization on top, and then kind of fit that into the same kind of pipeline as before? How does it change how you're working day to day?
So what we found was that in terms of the research phase, it had, I mean, the shift wasn't so. I mean, we were able to adapt quite easily to working in container environment. I think where the main sort of the main improvement in our workflow will be productionization, and so I mean, currently it's actually very, very convenient and very easy environment to adapt to. So that's what we found.
I think for us, it removes the initial research that we had to do to figure out how to do those optimizations on the AWS platform and the setup phase. Now we can just pull that container and then, yes, do any additional customizations depending on the context that we want to use it in. We can also scale more easily, so when we're going from POC, kind of a proof of concept prototype, to a full deployment, we can increase our containers appropriately instead of relying on the AMI-based instances that we did before.
And one thing that we've been very conscious about and intentional on is making these Docker images as minimal as possible, because we want customers to use these deep learning container images as a base and then customize on top of them, add their own custom frameworks, tooling, code, agents. So unlike the deep learning AMIs or AMIs, they have
new and terrible.
New and terrible. The deep learning containers are meant to be a base for everyone. And then you can build on top of that base, you can make a new Docker file that lives in ECR, or you could do something on the fly.
So a question from Twitch. Yeah. We're going to go back to basics for a second.
Sure.
Who wants to give us a really kind of high-level overview of what deep learning actually is?
How about Mayor with the Photoshop use case?
So,
which we'll actually see in a later session as well, so maybe we could just get a quick overview.
So, just as an example, so what differentiates deep learning from, let's say, machine learning or data science?
All the learnings.
Yeah, all the different learnings. So, fundamentally, deep learning is an extension of machine learning in that instead of explicitly writing code to perform tasks, we train models to learn from data to perform a certain task. What makes deep learning different is that the models are typically larger or deeper, so to speak. Instead of having a few parameters to your model, you now have much larger parameters which actually have depth. And the initial motivation behind that was to model the way the brain processes data, in that you have neurons that have layers and signals that pass through those layers. So deep learning is sort of an abstraction of that idea, but it's sort of on a high level.
Rohisha, what's your take?
Yeah, so deep learning is just another way to increase our predictive power in certain contexts. So it's a type of machine learning. It's also enabled things like computer vision, natural language processing, speech recognition, which weren't really possible with classic machine learning. So I think it's just an improved type of machine learning that can be especially useful in certain contexts.
I think a practical question from me is, how do I get started with this? So with the deep learning containers, how do I kind of go from fun keynote announcement to using it myself?
It's a great question, and we will actually have a session on this right after at 5 p.m. So the quickest way to get started is you find the deep learning image that you would like to use in the Elastic
Where do I
Container
look
Registry.
for it?
So we have in the user guide and documentations, if you go to aws.amazon.com/machine learning/containers, you will find the deep learning images listed, and each image is built and optimized for a specific use case. So training in TensorFlow with GPUs on a specific version of Python for TensorFlow. And you can then just do a Docker pull in an EC2 instance, or you could specify the full image URL in an ECS task definition, and then you would get the same native benefits of ECS in setting up scaling clusters and using all the great functionality and features that ECS brings, and then the same thing holds true for EKS. So you can specify the deep learning container image in a pod YAML file, and then you are in a native EKS environment. So all the functionality that already exists in EKS or Kubernetes comes for free, and was again a very intentional choice. We didn't want to create any new concepts here. So the way you would pick any Docker image and use it with your existing workflows, the same holds true for deep learning containers.
So building off of that, there was a question in Twitch about CloudFormation. The deep learning AMI or AMI or AMI is
What have I started?
pick one. That's supported with CloudFormation for the new releases of the AMI. For the images, you don't really need it. You can write your own deployments if you want to automatically pull an image from a registry and update your task definition. Kind of works. I think what we're getting at, right, is that it works the same as any other image. So if I hypothetically knew more about deep learning than I do, I maybe would put the image. I would make the changes or customizations that I needed to locally. I push it somewhere else, and then I can automatically update my task definition or my EKS pods with my changes.
And so customers that have an existing workflow or pipeline set up using ECS or EKS, they just need to swap out the images, and everything is already set up for them.
Right. So I can have different environments.
Yep.
Right, like I could for anything else. What have I not asked that I should have asked about either how you guys are using things in production, kind of what's next, about your workflow that you think that Twitch should know that I didn't cover?
I think one thing that would be interesting to highlight is the deep learning containers have been built to be integrated fully with EKS and leverage EKS's performance at scale. So if you're looking to do distributed training, multi-node training in TensorFlow, that's one of the areas where we've really optimized these deep learning container images to get customers the best scaling efficiency possible in AWS. And as we showed in the keynote today, that scaling efficiency in TensorFlow is almost 90% right now.
I'll try to post some of them in the chat, but there's been some really cool posts about, I've been surprised at how big kind of the deep learning, machine learning community is around Kubernetes and around EKS. So we'll see if we can throw some of those links in the chat.
Yeah, and I think that's another great example of the contrast between the AMI and the container. So if you're doing distributed training with an AMI, you have to spin up your cluster, manage the communication between those instances, edit the local host files. When you're doing EKS, you can use something like EKS CTL to say, I want 4 nodes, and you guys figure out the rest, and EKS does. And
yeah. I think something that it's been really interesting to me, especially about something like deep learning or machine learning, which I hadn't really done a lot of before I got here, is that how much more accessible they're starting to feel with images being passed around or AMIs being passed around or config files, or that I can just pass an image and then let my container orchestrator deal with it.
Right.
It feels much more accessible than it used to feel.
Sure.
I might be making that up. Not making it up.
No, definitely.
Yeah, I definitely
very much
agree.
so.
Anything else that I'm missing that I should have gotten? Because I have one more question for you, unless I missed anything.
Anything else for you guys?
Anything that I should have asked that I didn't? Okay. So I think my last question is for you. A really quick one. Beyond PyTorch, what do you guys plan next around the container images?
So it's a great question. We've been very engaged with the community that's already using containers in AWS, and so we're listening to, including Abby, and we're listening and we're talking, in our roadmap is almost completely defined by what customers are telling us. So I think a few areas that we're excited about is making it easier to get started in ECS and EKS and Kubernetes. So how do we simplify the process of spinning up that cluster, setting up your Kubernetes so that you can take this image and then build a whole universe around it that becomes this automated pipeline and workflow. So I think ease of use and the getting started on ECS and EKS, and then looking for every optimization and improvement to the framework we can make.
Awesome. Guys, this has been great. Thank you so much for joining me. We are out of time, but we will be back with another session here on twitch.tv/AWS. Thanks, everyone.